Hi everyone. So for this week, week 10, we're going to be doing lesson 11 for geometry. Now, in previous weeks, including the CFA last week, we looked at transformations and looking at the difference between reflections, rotations, and translations. What we're doing this week is diving more deeper into each of the different types of transformations, just so we can further understand the depths of each. Now, this reflection first is going to be the one that we're focusing on today. Here is a GIF of a reflection. So basically, when we're reflecting an image, they're always going to be reflecting about a line. Now, a line can be, this case, it is a y-axis. A line can be the y-axis, but as you know from last week, we have lines anywhere and you can reflect lines from anywhere. So what we should notice is that since we're reflecting, this graph or this shape is going to be equidistant or the same distance away from the line of reflection. So B is going to be 2 units away from the line. Therefore, B prime right here is 2 units away from the line. 2 units away, 2 units away, and then point A is 1, 2, 3, 4, 5 units away, so A prime should also be 5 units away of the line. We're going to be practicing a little bit of that, and then today we're going to be doing an Edpuzzle. So you're going to be watching you'll be watching what I do, and then you're going to be answering questions based off of that. So first, what we're going to start out with, let's see here, is the student website for defining reflections. So basically, as you know, we're going to be looking at reflections, but to start off, here is the first problem. So it's which one doesn't belong crossing the line. So each of these figures has something unique about it. I'm going to go ahead and then show this a little bit more clear so you can see the difference between figure 1, 2, 3, 4. And I'm going to pause this video and you're simply just going to watch this video and then you're going to write down some things that you noticed, but mainly I want you to see what doesn't belong. Now, you can write something for figure 1, 2, 3, and 4 about why each of these are different and why one of them does not belong. After you've taken the time to write about different items, I'm going to go ahead and say a few things that you could have noticed and said. However, there are many, many other things that could have been noted. So the first step, just by looking at it, is this is the only one that does not have a 90-degree angle. Figure 2, 3, and 4 each have a 90-degree angle that is shown by the 90-degree angle sign, the right angle sign. So you could say that is the reason why figure 1 can be crossed out. Now, if you're looking at figure 2, the difference between figure 1, 3, and 4, figure 2 is the only figure that has segments on either side of the vertical line that are not congruent. So 4 and 6 are obviously not equal, whereas figure 1 has 5, figure 3 has 5, and figure 4 has a length of 7 units across. And those are indicated not only by the number that we see, but also by the little matching hash mark. Now, figure 3 and figure 4 are very similar. What you're noticing, though, with figure 3 and figure 4 is that figure 4, A and B are different points. Figure 3 has C and C prime, and C prime indicates that C prime is a copy of C. We always know that by the little hash mark that's provided. So anytime that there's a little hash mark, that means it's a reflection of something. To review that again, we can go back to this image, and when this image A, B, C is flipped, it turns to A prime, B prime, C prime, because those apostrophes signifies a prime or a some sort of transformation occurred. Alrighty. So after we did 11.1, we're going to skip down to 11.3. So basically, a student is looking at the shape CDE triangle, and we're reflecting it across line M. So far, he knows that E is E prime and D is D prime. We know that for certain. Now we have to figure out what is how we can write down E prime. So first, annotate the diagram to show how he reflected point D. So if you're following last week, you know that we were able to use these different tools to create new shapes. So if we're looking at, this is the reflection tool, and when you click the reflection tool, you're able to, you can see, select the object to reflect and then the line. So I'm just simply going to select D, select the line, and you're going to see it made a second dot right where it was the original. So you can explain it however you would like about how did, let's see here, how did they reflect point D. use your own words. I'm going to go and pause this video, but you can say anything in regards to the reflection tool that you had to use, or that D is the same distance away from the line M. Now what we have to do is we have to find where C prime is. So C prime is going to be in this general area, and there's a lot of ways that you can do it. Now, about 2 to 3 weeks ago, we learned about perpendicular bisectors and how to create that, but I'm going to show you a way of how you can create mirrored images of points on GeoGebra. So the first thing that you can do is simply, let's see here, I'm going to be making line segments from, oh, that did not work, now did it. Let's see here. Okay. So I'm going to be making, I'm going to undo everything that I have. I'm going to be making line segments. Interesting. From E to E. Line segment from E to E. I'm also going to be making a line segment from D to D. Now, I know for sure that this C to C is going to be, the C is going to be around here somewhere. So what I can do is create a point oh, wait a minute. I don't know why I blanked out. Okay, so what we can do really fast is there is a reflection tool. So simply select C and then select the line, and then there is my reflection tool. And what I can do is I can double check that and then go ahead, draw a line segment. And what I will do is I'm going to indicate every single point in the middle. Okay, I can tell that's a little offset, but that's okay because it didn't turn automatically black. So I think I can adjust it and it will just hook onto the original graph. All right, so now what I can do is I can use circles because circles have the same radius if I select them, and I can overlap them just to make sure that these are going to be correct. So here's this first one. I'm going to select this, I'm going to select here my C, and then I'm going to drag it to the middle. I'm going to do the same thing by selecting this, selecting the C, and then dragging it to the middle. Now, in order for me to double check that this is actually the same thing, this was a circle creation tool. I'm going to use a compass tool so I can move around my shape. So I'm going to select this, select the segment for the radius, and then the center point. So here's my center for my radius. Here's my center point. Oops. Let's see if it will work. Center for my, so that's my 2 points. So I just made this one right here, C, original C. I'm going to drag this over to this one and notice that it was an exact match. So that's one way how you can make sure also that they are points of reflection. Now what I can do, I'm just going to hit undo to fix it, and I'm going to select my shape tool, and I'm going to connect these lines. Oh, let's see here. Oh, this is my shape tool. Polygon, select all vertices. All right, and now I close my shape. So this shows us how I can do number 2. Now, it says write a set of instructions for how to reflect any point across a given line. So once again, when I went to C to reflect it to the other side, or if that were any point, let's say a random point P over line M, I can simply, and actually this is what I'll do, I'll make a point, this is point P. Line M will be 10 as line L. So I'm going to select my reflection tool, select my object to reflect, and then my line of reflection, and now you can see that this is the reflected point. So once again, the steps are create a point or any point that you have, select the reflection tool, then select the object and then the line, and then it will automatically reflect. Pause for that. Last but not least is this next image right here. So first we said Elena found C prime incorrectly. So we see the diagram. She's convinced that triangle C prime, D prime, E prime looks fine, but we have to explain to her why it's not a reflection point across line M. So I'm going to make this a little bit bigger so we can see. Alrighty, so what we're doing right now is we're noticing that this is a attempt at a reflection. So if you're looking at the line, E and E, D to D, and C to C all appear to be triangles. They all appear to be somewhat similar to each other, but if you look a little bit closer, you can notice that there's a slight difference where C is here on the orange and where C is on the blue. What you should notice is that this C to D is a lot smaller and a lot shorter distance, or sorry, C prime to D prime is a lot shorter distance than the C and D line segment over here on the blue triangle. So we know that Elena cannot have had an accurate graph or an accurate drawing just because this line segment is way too long. And if it is too long, we know then that the distance between C and then the line must be different because it's not exact than the distance between C prime and then the line there as well. So make sure that when you're answering the last question, you're answering the following. Explain why to Elena her C prime is not a reflection point C across line M, or in this case, it was the L that we used earlier. Alrighty. So last but not least is a summary for this week's lesson. So the summary is that think about reflecting point A across line M. So we have light right here and we, selected the reflection tool and we made a light right there. The image A prime is somewhere on the other side of L. Right around there. The line L is the boundary between all the points that are closer to A and all the points that are closer to A prime. In other words, L is a set of points that are the same distance from A to A prime. So L is going to be made up of all the different points that are equidistant from A, whether it's a shape or just a singular point. A as from A prime is a perpendicular bisector of line segment A to A prime. Using the construction technique from a previous lesson, we can construct the line perpendicular to L that goes through A. So notice here that A is written down and that they drew a line from A to the other side using a 90-degree angle, which you can see up there. Now what we do is we have a circle to kind of connect both points. And then once you connect both points, you're able to notice that this angle and this angle, or sorry, this segment and this segment are all going to be the same distance. And then for their glossary entries, assertion, that is something that has been true but not yet proved. So like making an assumption. Congruent is called congruent because, A turns to B by translating or sliding. B turns to C by reflecting, or no, by rotating, and C goes to D by reflecting. And then the vector right here is blue. This is signified by either a change in coordinate points or by giving you a line segment with an arrow attached. Reflection is simply a reflection. It's a mirror image. And then rigid transformations is when something is always slid over, rotated, or when it is reflected. And that is it. What you're going to be doing later this week is you're going to be going through and completing a systems practice problem, which will be linked as well.